Hello everybody, welcome to class today. Back after our week off, having another live stream. I hope you all enjoyed your week off. Got an opportunity to rest, maybe visit the fair. This week we're back at the grind. And we're in Module 5, and we're talking about common support problems. So, as a support agent, there are some things that you're going to see over and over and over and over again. And sort of the idea behind this module is to kind of prepare you for the things that you're going to see on a regular basis. So we kind of take these things that you're going to see regularly and we break them down into categories. And the categories of our most common support problems or our most common end user problems are thus. We have hardware problems, software problems, network problems, user problems, security problems, documentation problems, vendor problems, and facilities and operating environment problems. And during our time together today, we're going to cover as many of these in somewhat of depth as possible. And there is one of these groups of problems that you're going to encounter more than the rest. And so we at least want to get to that one today. So we're going to start off by talking about hardware problems. And when we're looking at hardware problems, we can even take the issue of hardware problems and we can break hardware problems down into subcategories. So when we're looking at the main category of hardware problems, we can take the issue of hardware problems and break it down into these four subcategories: hardware installation, hardware compatibility problems, hardware configuration problems, and hardware malfunctions. So under hardware problems, we have these four categories that are all issues that cause hardware problems. So let's have a look at some of these. When we're looking at hardware installation problems, hardware problems can occur during the installation of new systems or during the upgrades of existing systems. So when we're talking about installation, we're talking about both of these things. When we're taking a new system and installing it into an environment, or when we're making upgrades to an existing system. When we're making upgrades to an existing system, one of the issues that we can run into is that we have incompatible components that are unable to operate together in the same system. And this could be due to just being improperly purchased, which isn't as much of a problem anymore, or it could be due to incorrect installation. For example, the example given here is, one of the best examples that we could probably give for incompatible components for an upgrade of an existing system being that incompatible RAM memory expansion. When you're installing RAM likes to be installed with like RAM. If you install RAM that's different, that's incompatible with the other RAM that's already installed in the system, you'll run into some issues with the way the memory handles things in the system. So in that sort of way, the hardware installation causes problems to the system at large. But this also lends itself to hardware incompatibility, which is something that could have been mitigated by the individual doing the upgrades. So this is something to think about from both sides of the issue here. One, as somebody going into this as an individual fixing the problem. You know, if you're doing that root cause analysis and you have these memory issues and you're wondering like, oh, okay, I wonder what could be causing these memory issues. Let's go backwards. Let's do that root cause analysis. Let's try to figure it out. And eventually through that research, through that root cause analysis, you determine, oh, there's incompatible hardware that's been installed. You keep that open mind as that being a potential solution, and you're able to understand the problem and fix the problem. We're also looking at it from the other side of the coin, however, as someone who, you know, when you're working in a help desk capacity or in a customer support capacity, you might be the one who's asked to do the upgrades of existing systems. So you have to go into upgrading existing systems with the understanding that hardware installation problems happen. And you have to go into it with the knowledge that you need to do your due diligence up front to understand what kind of hardware is currently in the machine and what you need to do to make sure that you get compatible hardware to go into the machine for upgrades. Otherwise, you know, you're wasting time, you're wasting money. And, you know, when we've been talking about efficiency over the last several weeks and trying to maintain, you know, business continuity and things of that nature, that's not going to do it. You know, a little extra time for research up front and ensuring that we're getting the correct hardware that our existing system needs to be upgraded. That little extra time up front can save us a lot of extra time and a lot of extra money down the road. So we're thinking about this issue from both sides of the coin at this point. We also have hardware configuration problems. Hardware configuration problems result when hardware or even the software that's on the system has component settings that are incorrect for a specific operating system. This isn't as big of a deal anymore. Now that we have plug-and-play standards in place, plug-and-play standards kind of override a lot of the old issues that you'd have with hardware configuration issues. You know, everything's kind of standardized, everything's in place, everything's understandable. We don't see a whole lot of hardware configuration problems anymore. One place where we do see hardware configuration problems in consumer goods is with display card settings. And, you know, this could also be considered a compatibility problem when you consider, you know, how I configure a graphics card versus like what kind of monitor that I have attached to my system. You know, certain monitors can only support certain levels of display, and you know, graphics cards are typically good about understanding what the monitor can display, but sometimes you get them where you can set them outside of those parameters and then the monitor can't support it and you don't get a picture and you have to kind of figure out what's going on. And in that case, it's a hardware configuration problem. But hardware configuration problems also tend to lean toward another problem that we'll talk about in just a moment. That's more common. But in talking about plug and play standards, just so we are clear, I think we've talked about them briefly in the past. But, plug and play standards are industry-wide protocols. So these are agreed upon standards that are followed by hardware vendors and operating system creators. So we have specific communication methods that an operating system uses to recognize and incorporate hardware components into a system. So when you hook up your printer, or you hook up even an internal component like like an add-on USB card, things of that nature. Thanks to these standards that the industry has kind of adopted, they're not required, but they're generally agreed upon, and because it makes life a whole lot easier and it makes people a whole lot more likely to purchase and work with you if you have something that's easy to use. You just take it and you plug it in, and the operating system has the things in place where it can understand what's going on because of these communication methods that are built in. And so configuration is automated to a degree. And in this way, it helps you load the drivers. Doesn't automatically adjust 100% of the software settings so that you can take maximum advantage of the hardware's capabilities, but it at least gets you functioning and gets you to that basic use. So this is why we don't see a lot of hardware configuration problems anymore. Hardware malfunctions. Actual real malfunctions account for a really small percentage of hardware problems. And we can reduce the number of hardware malfunctions if we work with a burn-in test when we install new hardware, because a lot of malfunctions that do happen because of hardware that's shipped that's kind of faulty to begin with. That comes kind of DOA, dead on arrival. So if we run it with a burn-in test, where we let it run for 48 to 72 hours in a new computer operating continuously, we can uncover obvious problems, and we can, kind of root out problems before they happen in a real working environment. And really the fix for a hardware malfunction is incredibly easy, because if you have hardware that malfunctions, essentially you replace it. We kind of talked about that briefly in the past. We're not going to spend a lot of extra time, like with the example here with inoperative keyboard keys. We're not going to spend a lot of extra time trying to figure out how to repair these few inoperative keyboard keys when we could just replace it with a new $15 keyboard. We could take hours and spend much more money trying to fix this problem than it would just to replace the unit. So with hardware malfunctions, the solution the majority of the time is to replace whatever is malfunctioning. So it's a fairly simple fix, and this is actually a small percentage of what actually has gone wrong. When it comes to what's most likely to fail, we're talking about electromechanical devices that have moving parts. So these are things like your hard drive, your standard hard drive with your electromechanical, with the arm and the platters and all that kind of stuff. And you might have had your hard drive die on you over the years. Just based on all of that wear and tear over time of all the moving parts going back and forth and doing all their job over the years. Because of all of that, it's a drain on the device. It wears it out. It's friction. And that's going to cause that device to fail. Least likely to fail are the pure electronic components. If something happens to one of these components, it's most likely that there was a flaw in the component to begin with. And that a system burn-in might have helped us root out that flaw if we'd have done it initially. CPU, RAM, solid state drive. These are things, there are no moving parts. They're just, silicon chips, integrated circuits with electricity flowing through them. These are the least likely to fail. Now, least likely still means that it can fail. So it doesn't mean that these will never fail. But they fail at a far lower rate than the electromechanical devices that have the moving parts. And again, there are plenty of hardware diagnostic tools out there. Boot disks, boot drives that you can use that help you identify system burn-in and hardware malfunctions. There are tons of them. A quick Google search can find you, dozens of these hardware diagnostic tools. And I think it even mentions some in your textbook. But you can create a boot drive or a boot disk and just have one of these and carry it around with you. I'd actually recommend you do that. You just create a boot drive, with Rufus and one of these hardware diagnostic tool ISOs. Put it on a flash drive, put it on your keyring. Then when you're in user support and you have to do some of these diagnostic tests, you can just whip out that flash drive, plug it in, boot to that flash drive, and run all the diagnostic tests you ever need to run. And you're good to go. And there are tons of those out there. Just a quick Google search will find you dozens of them. Let's talk a bit about software problems. And there were 4 subcategories of hardware problems. There are 5 subcategories of software problems. And you can see a lot of overlap in the types of software problems compared to our types of hardware problems. Our subcategories of software problems include software installation problems, software compatibility problems, software configuration problems, software bugs, and software performance problems. So let's talk a little bit about those. So, software installation and compatibility problems. Not so much anymore, but it used to be a thing where not all software installs automatically. Nowadays, pretty much every piece of software installs automatically. We've got, if you've ever installed software manually on Linux, you know how software installation works. Or if you've installed software on a server, you know how software installation really works. About compiling and all that kind of fun stuff. In order to make that whole process more friendly, vendors decided to create an installation software package for us, and that's a utility that handles the installation of all the software packages for us. So it gets that hardware configuration and then makes the software compatible, creates all the folders with the path names, sets the configuration options, copies the files to the right folders, updates the registry, and updates all the startup files, does everything that you would need to do in order to get that software up and ready to run. It automates that process for you. Now, one of the common carryover problems that we see is that application software is incompatible with a new operating system. I was just reading an article about older versions of VMware Workstation Pro, the virtualization software, and how the older versions of that are incompatible with the new Windows update that's coming out. So that's the kind of thing that you have to keep aware of. This is, this type of problem here is something that, just keeping yourself educated on is something that will help you solve these problems when they arrive. Software installation problems. This kind of conflict occurs when two software packages use system resources in different and incompatible ways, and this results in conflict. An inoperable system, poor performance, that sort of thing. Again, this is something that's not as big of a deal anymore. We've kind of had things standardized. So we're not really as worried about this anymore. But on older systems, this could be an issue. So I'm kind of leaving this in here to let you know, be aware that this is something that could potentially happen. Software bugs. A bug is a major error in a program due to a programmer's coding mistake, A, or B, a programmer's inability to anticipate every situation. So we have two conditions there under which a bug could happen. One's just a simple error, and two is that the programmer being one person or even a small team of people, couldn't possibly think of every single condition in which somebody might use the program or every single thing that somebody might do to a program, and then you just use it in that one right way that causes it to go crazy. Now, this is going to occur more often in custom written programs and programs that are written for a limited market segment, because all of the big AAA titles that have been written for large market segments, they go through extensive testing before they're released to the market, because they know how much it would cost them if something as big as, say, Microsoft Word got shipped with a huge bug that prevented you from doing basic functions. And there's also, a huge team working on these big projects. Whereas, with a custom written program or programs written for a limited market segment, those are much, much smaller teams, maybe even one person. And these occur most often in infrequently used features of a program. So if it's a feature that's not used very often, then it's not going to be tested very often because it's not used. So if you take that rarely used feature, you use it in a specific way, you throw a bug. The existence of bugs can be reduced through the use of extensive beta testing. Get a bunch of users, get them to use the software, get them to use it in every way possible. Try to root out all the bugs before it goes out into the market. One of the examples is incorrect format of large dollar amounts in an accounting program. There are rounding errors. Rounding errors in Java, for example, is a huge problem. So if you're, using Java without those rounding, using Java floating point numbers without those rounding errors being taken into example in an accounting program, over time you're losing a company a whole lot of money, and it's just a bug in the system. So it's problematic. Vendors fix bugs and upgrade software through patches and updates. These are just quick definitions that we'll go through. A patch is a replacement for one or a few modules in a software package to fix bugs that are known. And we usually designate this by adding a digit or a letter to a version number. And an update is a bug fix software release. So a patch is just a small little fix that fixes part of a piece of software that just has a few problems in it. Whereas an update is an entirely new version of the software that's fixed a bunch of bugs and that sort of thing. So, and some vendors offer automatic updates via the internet to download and install patches and keep the program up to date, so you don't even have to worry about it. Version numbering. And this is kind of important to know so you can kind of decipher all the version numbering. So when you get the first release of a version, that's typically denoted by the whole number. So the example here is 2.0. So it's 2.0. So it's version 2. So version 2.0 might be offered as an upgrade for purchasers of version 1.0. But we might release an update with a few new features, but it's not a whole new version. It's not new enough to call it a new version. Just have a couple tweaks, couple of new features. So that's just an update. So we usually add that in the tens place of our version numbering system. So if we release an update to this version 2.0, we'll call that a version 2.1. Bug fixes then go in the hundreds place. So if we have a bug fix, we'll put that in the hundreds place, call it 2.11. Alternately, if we released a bug fix before we released an update, that might be 2.01. And then there are also service packs, which are a collection of updates. So we might have several bug fixes that we put into a certain service pack and release it as a version. So 2.11, 2.12, 2.13, 2.14. Take all of those, package them together, and call it 2.1 Service Pack 1. And release that as a version that has all of the packed up together. So when you're looking at version numbering for software and deciding, okay, what's the latest version, what has the bug fix, what doesn't have the bug fix, what can I install on this person's computer, those are things to consider. Network problems. Let's talk about network problems for just a moment. We're going to run a little over time from what I normally like to run this week because I want to get to the next set of problems, because the next set of problems are the key problems. When we run into network problems are often a combination of the two types of problems that we've already talked about, hardware problems and software problems. Hardware problems in the servers, in the routers, in the access points, in the bridges, in the switches, in the gateways. All that stuff you learned how to work with in Net 125, Net 126, all your fun networking classes that you loved and enjoyed. Maybe they were misconfigured, maybe they were installed incorrectly. And software problems, operating system problems, iOS problems, Windows, Linux, Mac, or whatever problems for servers, or even workstation client software for configuration on host machines. The example given here is that the use of network monitoring software to detect a network bottleneck that was caused by inadequate free space on the server's hard drive. So, using some network monitoring software to see the bottleneck, see where it's coming from. Server has inadequate space on the hard drive, so it can't process all the information that's coming through because it doesn't have anywhere to put it. So it has to slow down and causes the bottleneck, and it figures out that that's where it is. And it's a combination of hardware and software problems there. There are other categories of network problems: installation of network hardware and software, compatibility of network components, network configuration, malfunctions, performance. This goes back into that whole, combination of hardware problems and software problems. We see those repeated here again. User problems. This is where I'll end today, is with user problems. The vast majority of issues that you will see come into your help desk center around user problems. And we take our user problems and we break them down into 5 categories: mistakes, misunderstandings, wrong products, inadequate training or failure to read documentation, and forgotten information. And that last one's one of the ones that we get the most here at CCC. But we'll talk about that in just a moment. A significant percentage of common support problems, I will even say the vast majority of common support problems, boil down to user mistakes. An errant keystroke, inadvertently selecting the wrong menu item and accidentally misconfiguring something, messing up the system just by accident. Doing something that, you probably didn't know everything about, just kind of poking around and then accidentally changing things and oopsie doodles. One of the solutions here is having a well-designed computer system. You want to anticipate potential user mistakes. This is something that we also talk about in my design class. We talk about anticipating how a user will interact with things and doing things like validity checks on data input. So if somebody goes to put in their email address, you want to check to make sure that it actually is an email address, or formatted like an email address. Alert the user to possible errors and provide corrective action. Give them the ability to go back and fix their mistakes when they make them. If they can fix their mistakes when they make them, that prevents us from having to fix their mistakes at the help desk. User misunderstandings are when product features or the limitations of products are not well understood. So the example here is that when user keeps hundreds of files in a top-level documents folder. So they don't have subfolders, or they don't know how to create and use subfolders. One, that's going to, make life a little harder on them because they're going to have a tougher time finding what they need. But 2, when it comes to file system management and the way Windows catalogs everything, that's going to kind of slow things down. Because that cataloging system is going to try to go through and catalog things, and, it kind of uses subfolders to help it categorize things so it can find things easier and that sort of thing. So having everything in that one folder slows things down when it's doing that cataloging. So they might notice a noticeable slowdown when they're using that folder and not understand. Wrong products. This happens a lot. Users don't know what to buy necessarily. And so they purchase or install the wrong product to accomplish a task. An example given here is purchase of a software package or a hardware peripheral that's incompatible with the system, or a purchase of a software without understanding the capabilities and limitations, or the knowledge of an alternative program. You go on and you see, oh, there's this cool software. I'm going to download it and try to use it. But they don't realize that, oh, it's a Mac software and it's only used for Macs, and I have a Windows PC and I can't install that on my computer. And they don't understand that. So one of the ways that we fix this is we fix it with education, and then we try to figure out a good solution for them that is comparable. Inadequate training or failure to read the documentation. The title kind of says it all here. Users can kind of be brave, right? We get this quick start behavior. A tendency, quick start behavior is a tendency among computer users to, say, I don't need the manual. I can do this. I know what I'm doing. I've used a computer before. I got this. I'll read the manual later if I have any problems. Let me at it. I can do it. And that ends up with the user wasting their time, wasting their effort, losing their productivity, maybe breaking something that requires them to come into us and try to have us fix it. And it's all because the user really doesn't know. They haven't been properly trained. They haven't read the documentation. They just try to jump in, do it, and more power to them. But it's kind of human, and it is human nature for us to want to do that. That's why we have this. It's why we have a name for this behavior. It's something that we want to do. But, it doesn't really work out. So, it helps to kind of educate our users. Educating the user. You'll hear me talk about it several times over the next few weeks. Educating the user kind of becomes paramount when we're dealing with preventative measures for customer support and user support for technical issues. And finally, forgotten information. Users forget information. This is something that happens a lot here at the CCC Help Desk. Forgot my password, forgot my username, don't know how to get in my email, don't know how to get into Blackboard, don't know how to do this or that. If any of you have ever worked the help desk before, you understand that that's one of the things that you get a lot of calls about. And, we forget. And, some people don't really know how to handle their data like that because it's not something they're accustomed to. So we have solutions here again, and reference sheets are an effective aid to recall procedures. So if they say, oh, I don't know how to log into Blackboard, you give them a reference sheet that says, go to clevelandcc.edu, click the login button, enter your credentials, and and then click the Blackboard icon, and then you're into Blackboard. Now, we do have a tip here that says users should be encouraged to write down a reminder of their passwords instead of the passwords they're set themselves. Because when we talk about security and system security, it's easier to kind of finesse and hack a person than it is to hack a computer. It's easier to find a Post-it note with somebody's password on it than it is to try to hack and guess and, brute force and all that kind of fun stuff. So if they just have a reminder of their password that at least presents a level of obfuscation between the would-be ne'er-do-well and gaining access to the system. So again, what we're talking about here is another issue of education. Trying to teach your user best practices, teach your user how to do things because they may not be accustomed to interacting with things in that sort of way. So this is where I'm going to stop for this week. I'm going to turn back on the music for a few moments and answer questions in the chat if anybody has any. But I want to thank you for coming, and I hope to see you next time. Thank you.